In this video, we'll solve quadratic equations using the technique of completing the square. Now that we have learned how to create perfect square trinomials, let's use this technique to solve quadratic equations. Our steps for completing the square are as follows. First, the leading coefficient must be 1. If the leading coefficient is any other number, you want to divide all terms on both sides of the equation by that leading coefficient A. Next, we get the variable terms on one side of the equation and the constant term on the other side. We've learned that we need to add b divided by 2 squared to our variable terms to create a perfect square trinomial. To keep it legal, we need to add this number to both sides of the equation. Then we'll factor the perfect square trinomial into the form x plus b divided by 2 quantity squared. And lastly, we'll apply the square root property to solve the equation. Let's solve x squared plus 2x minus 5 equals 0 using completing the square. First, we want to make sure that our leading coefficient is 1. It is. Great. Now we want our variable terms on one side of the equation and our constant terms on the opposite side. So let's add 5 to both sides. You'll notice that I am leaving a space after the 2x. This is just a spot to put the b divided by 2 squared term. To create our perfect square trinomial, we want to add b divided by 2 squared to both sides. In this example, our b value is 2, so we're going to take 2, divide it by 2, and square it. 2 divided by 2 is 1, squared is 1, so we're going to add 1. And we know we need to do it to both sides of our equation to keep it equal. On the left, we've created a perfect square trinomial. This perfect square trinomial factors into the form x plus b divided by 2 quantity squared. Your b divided by 2 is the number that you had right before you squared it. So the factored form of x squared plus 2x plus 1 will be x plus 1 quantity squared. Combining like terms on the right, we get 6. Now we have an equation where we can solve using the square root property. I'm going to take the square root of both sides. On the left, the square and the square root cancel out, leaving us with x plus 1. And on the right, we'll have plus or minus the square root of 6. You want to try to simplify the radical. It turns out that the square root of 6 does not simplify. So now we want to go on to solve for x. All we need to do here is subtract 1 from both sides. We end up with x equals -1 plus or minus the square root of 6. Let's solve 4x squared minus 4x equals 7 by completing the square. Well, right away I noticed that my leading coefficient isn't 1. So that my first move is to divide every term by that leading coefficient. This leaves us with x squared minus x equals 7/4. To create our perfect square trinomial, we want to add b divided by 2 squared to both sides. When you're looking for your b value, you're now looking at this equation. Once we've divided through by 4, we don't ever go back to the original equation. So our b value is going to be -1. We take -1, divide it by 2, and square it. Well, I can't divide 2 into -1, and the fraction doesn't simplify anymore, so we're ready to square. -1/2 squared will be +1/4, and I'm going to add 1/4 to both sides of my equation. We've created a perfect square trinomial on the left that will factor into the form x plus b divided by 2 quantity squared. Remember that our b divided by 2 value is the number that we had right before we squared it. So this time, b divided by 2 is negative 1/2. This factors into x minus 1/2 squared. We want to write x minus 1/2 rather than x plus a negative 1/2. And then combining our like terms over on the right side, we get 8/4, which simplifies down to just 2. We have x minus 1/2 quantity squared equals 2. This is an equation where square root property can be applied. Taking the square root of both sides, on the left, the square and the square root cancel out, leaving us with x minus 1/2. And on the right, we'll have plus or minus the square root of 2. We want to try to simplify the square root of 2. It doesn't. We got one more step to solve for x. We'll add 1/2 to both sides. We get a final answer of x equals 1/2 plus or minus the square root of 2. Next, we want to solve 3x squared plus 10x plus 12 equals 0 by completing the square. Again, I notice right away that my leading coefficient is not 1. We're going to divide each term by that leading coefficient of 3. This gives us x squared plus 10/3 x plus 4 equal to 0. Next, we want our variable terms on one side and our constant term on the other side. So let's subtract 4. That'll give us x squared plus 10/3 x equals negative 4. We're ready to create our perfect square trinomial on the left. We do that by adding b divided by 2 squared. Our b value this time is 10/3. We're going to divide that by 2 and square it. We're going to shift our thinking a little bit. When you divide a fraction by a non-fraction, like 2, instead of thinking division by 2, we want to think of multiplying by the reciprocal. 10/3 divided by 2 is the same as 10/3 times 1/2. 10/3 times 1/2, I'm going to do some simplifying here, gives us 5/3, and we still need to square that. 25/9 is what we'll be adding to both sides. We've created a perfect square trinomial on the left. This always factors into the form x plus b divided by 2 squared. Remember that our b divided by 2 is the number that we had right before we squared it. b divided by 2 this time is 5/3. Our left side factors into x plus 5/3 squared. And on the right, we'll need to get a common denominator and add those fractions together. We end up getting negative 11/9. And we have an equation where square root property can be applied. Taking the square root of both sides, on the left, our square and square root cancel out, leaving us with x plus 5/3. On the right, we have plus or minus the square root of negative 11/9. We want to try to simplify our radical, and this time it does simplify. Remember, when simplifying a fraction underneath of a radical, you want to split it up. This will be the square root of negative 11 divided by the square root of 9. We have a negative underneath of our square root, so we'll pull out an I. We get I square root of 11. The square root of 11 does not simplify further. Turning our attention to the denominator, the square root of 9 is a perfect. We get just 3. The square root of negative 11 ninths simplifies to I square root of 11 over 3. So we have x plus 5/3 equals plus or minus I square root of 11 over 3. The last thing we need to do to solve for x is subtract 5/3 from both sides. We get a final answer of x equals negative 5/3 plus or minus I square root of 11 over 3.